All right. So, hello and welcome everyone. So, we are live right now. So, I welcome all of you to this amazing platform of Tutee Learning. I hope I'm audible to all of you. Right. So, today, as we were discussing with our ongoing lectures on ellipse, so today we will discuss about some of the important properties of ellipse regarding tangents and normals. Right. And with that, we'll also try to solve some of the important problems which are very relevant, especially for your upcoming JEE mains and advanced examination. Okay. So, keeping all these things in mind, let us now today discuss about some of the key results that are really important, especially when we go on to solve the questions on ellipse, right? So, if I talk about all the important results of ellipse, we'll see that there are some of the important results that are mostly being asked in the examination. Okay. So, to begin with, if we talk about the most important results or the crucial results, especially to the ellipse, are basically the tangents and normals, right? So especially in any questions of conic section, you will mostly see that the questions are, most of them are actually based on your concepts from your tangents and normal, right? So having that particular thing already done, so now we come to the general discussion that what happens to different form of ellipse, right? So today in this particular lecture, I'm going to briefly discuss about another very crucial result, that is what happens for equation of equation of tangent to the ellipse, equation of tangent to the ellipse. Now previously we have learned about the equation of tangent to the standard ellipse, right? Now what happens if you have the equation of an ellipse in some different forms? Okay, if you have some different form, then what happens to the equation of the tangent to that particular ellipse? Okay, so let us try to analyze and see that in this today's lecture. Okay, so as shown above, the various different equation of tangents was basically expressed for the standard forms, and if we recall, for the standard equation of ellipse, which was basically given as x square by a square plus y square by b square is equal to 1, which is basically the standard form of the equation of ellipse. So to the standard form, if I want to write down the equation of a tangent, so we have already seen that there are multiple different forms to it. So let us say I want to write down the equation of tangent at a point whose coordinate is given as x1 y1, right? So if you want to find out the equation of the tangent to this particular standard ellipse at this point x1 y1, then it can be easily done as by doing that modification, that is t is equal to 0. So that basically gives me that x1 by a square plus y1 by b square minus of 1, this particular thing should be equal to 0, right? So if I equate this part to 0, we'll easily get the equation of tangent at any point. In the similar manner, if I want to express this x1 y1 with this coordinate, that is over here as a times cosine theta comma b times sine theta, then the equation of tangents can also be given as, so we'll have x cosine theta upon a plus y sine theta upon b minus of 1 is equals to 0, right? So this was the parametric form. Now also we have learned that in the slope format, if I want to write down the equation of tangent, that is already known to us. So that is basically y is equal to mx plus or minus square root of a square m square plus a b square. So this was what we have already discussed in our previous lectures, right? But today what I'm going to discuss is that what happens if I have a line. So in if I want to talk about the general case, what happens for the general case, right? So let us take the general case. So in general, so if I take a general case of a line equation Lx plus my plus n is equal to 0, and if I say, or I might also take a line equation in another format. Okay, let us proceed with this particular format first of all. So if I say that this is a tangent, to the ellipse, so we have already seen that if this is a tangent, the condition of tangency was a m squared. So here your m is l by minus of l by m. So it would become n square is equal to a square l square plus b square m square, right? This is what we have already seen, right? But what if I want to give you a general line equation as follows? Let us say I give you a general line as, let us say the general line looks something like x cosine c plus y times sine c is equals to L is a tangent to this particular ellipse. Then the tangency condition says that you'll have L square is equal to c square cos square alpha, so plus b square sine square alpha. Okay, so this is the tangency condition for your given problem, right? Oh, sorry, it's not, should be not be alpha, it should be a, right? So a is basically for that standard ellipse, right? Now the problem can also be asked as, what if I have a very standard equation of ellipse, right? So if I have a very standard equation of ellipse, let us say the ellipse is bit of tilted, something like having um, the minor or the major axis along some line equation, right? Let us say the ellipse is something like this, right? So which is a very standard equation, which is not a standard equation of ellipse, so it's a any general form of ellipse equation. Then how do we find out the tangent to this particular kind of ellipse, right? So let us say I have to find out the ellipse at any given point P. Okay, now again, if you recall from my last class, we have been discussing that in order to find out the equation of the tangent at this point P x1 comma y1, we need to know what will be the equation of or the slope of this tangent, right? So slope of the tangent, the slope of the tangent to the ellipse can be given as dy by dx, at that particular point, right? So we have to apply a bit of calculus to basically get to that particular form, right? So if you have a confusion that what if the standard equation is not given, so the only way out for that particular type of question is basically to apply the calculus. Okay, so you have to differentiate that particular function with respect to x at that particular point to get the slope of the tangent. And similarly, if you want to find out the slope of the normal at that particular point, that can also be obtained as negative times inverse of 1 upon dy upon dx at that particular point P. Okay, so this will generate you the slope of the normal. Okay, so this will give you the slope of the normal. Okay, so this will give you the slope of the normal. Okay, so these are the few of the important applications or a simple usage where you are not given the standard equation, however you have to find out that what happens for those kind of cases. Okay, so I think with this particular part we are almost done. However, there is another very important relation, that is something called as orthogonal tangents or the concept of director circle. Okay, so if you recall that director circle was basically the locus of the point of intersection of orthogonal tangents. Okay, so it is basically the locus of point of intersection of two mutually perpendicular or mutually orthogonal tangents. Okay, so to any curve, okay, to any general conic section, okay, to mutually perpendicular tangents. Okay, so the point of intersection, that locus of that point of intersection to that particular curve is basically called as a director circle. Okay, so if I take this case of the ellipse over here, so for the case of an ellipse, so if I say this is my standard equation of an ellipse, which looks like this, x square upon a square plus y square upon b square is equals to 1, which is the standard equation of the ellipse. Okay, then if I take up 2 points from which I draw mutually perpendicular tangents, so let us say the tangents are drawn in such a way that they are mutually perpendicular, and these tangents drawn at point A and B intersects at point P, right? And I have to find out the locus of this point P over here, right? So if you do it, you will see that this locus of this point P will be a circle, and that particular circle is also called as a director circle, or it will be basically having the equation as with the center as 0 comma 0, and the equation of the circle will turn out to be x square plus y square is equals to a square plus b square. So this is the circle equation that we will obtain, or this is the director circle. Okay, so this is the director circle. So this is my director circle. Okay, and director circle is also called as orthotropic curves. Okay, or also known as orthotropic circle. Okay, ortho orthotropic circle. Okay, so these are the different nomenclatures that we use. So please note that for this ellipse, it is not to be confused that with that of a circular directrix. Okay, so these are some of the important applications that you will see in case of an ellipse, right? However, ellipse, we have already seen that it is a perfect example of, so it is a perfect example of or something called as elliptical reflector or in acoustics, right? So in our previous class, we have seen that ellipses are generally used as elliptical reflectors or in acoustics as well. Elliptical reflectors and acoustics, where one of the key importance of the application of ellipse is that, so if you have an ellipse and if you have a any sound emitting or a wave emitting source kept at one of the focus of the ellipse, after getting reflected from the ellipse surface, it will definitely pass through this point or the other focus. Okay, so this particular phenomena keeps on happening. Okay, so this keeps on happening, they get reflected and pass to the other focus. Okay, so this is one of the very important applications of ellipse, and it has been used in multiple different applications of engineering. Okay, also even in our planetary movements, where we have already we have studied that elliptical orbits are there, right? So in case of the Keplerian elliptical orbits or those things where you study the gravitational attraction of the two body problems, you will definitely have seen that the path along that body traced by it is basically along that of an ellipse, right? So in doing those calculation also, you will definitely be using this concepts of ellipse as well. Okay, however, ellipse are also used as a case of an harmonic oscillators as well. Okay, so there are multiple different examples, even in statistics, even in physics, even in optics. Okay, so there are multiple examples where we have to use ellipse. Okay, even in optimization theory, there is one of the very famous methods, something called as the ellipsoidal method. Okay, so having all these things being said, I think we are mostly done with our important parts regarding our ellipse discussion. Okay, so now I think we are almost ready to discuss about some of the important problems. Okay, so if you have any questions, do let me know so that I can be there to help you out with your queries. If you have any question, do let me know in the live chat. TV gaming, hi sir. Sir, discuss about the properties of parabola. Sir, how to remember the properties of ellipse? See, TV gaming, you don't have to remember the properties of ellipse. Okay, those properties which are very relevant and important, I am basically listing it down over here. Okay, and remaining all those other properties which are not that important is not required to be remembered. Okay, so in different types of questions, by doing on question, we will be able to understand the different properties. Okay, so that is a key advantage that we can take over there, right? And regarding properties of parabola, I have already discussed that in the parabolas lectures, right? Whatever properties I have discussed in parabola, those are the important properties. However, if there are some properties which I feel is also important for exam purpose, I might also discuss in terms of questions. Okay, but I think I have already covered up all the properties of parabolas. Okay, is that clear to all of you? Is this part clear? Okay, so now another important types of question that actually comes up in exam is the question of common tangent. Okay, now this is a very crucial and an important question that you will see mostly in JEE mains and advanced. Okay, that is the common tangents between these conic sections. Okay, so how do we find out this kind of questions where we have to find out the common tangent? Now this is a very crucial and important question that I have seen many students to struggle with. Okay, so the easiest way to begin with this kind of problems is to assume the common tangent slope to be m, right? So let us assume this common tangent slope to be m. Now let us, for simplicity, let us take two examples. Okay, let us take two cases where I want to find out the common tangent to the standard parabola and the standard ellipse. Okay, so we take these two curves and for which I want to find out the common tangent, right? How do I proceed for this question is very simple. We have to first of all assume a tangent of the slope m, and we have to write down the equation of tangent for both the curves. Okay, so we will write down the equation of tangent in the slope format for both the curve, and then we will equivalent, and then we'll, by equivalence relation, we'll try to equate both of the equation of tangent. Okay, so once we write down the equation of tangent in the slope format, we'll try to equate both the tangent equation, and from there we'll try to get out the important configurations in the common properties, right? So from there we will be able to get to the values of this unknown the slope of the common tangent, right? So once we get to the slope, we can easily write down the equation of tangent by using any of this form, right? So this is a basic way to solve question. However, in questions we will see that there are some kind of algebra that we have to evaluate, and from there we'll be able to say or find out the questions in a easy manner, right? I hope this is clear to all of you. So with this part, we proceed for our next discussion. Also, another important question that you can definitely see in case of an ellipse is that, so in an ellipse there is a concept of co-normal points, right? So if I take as similar to that of a parabola, so in an ellipse, if I take out 4 points on the ellipse, let us say this is A, this is B, and this is C, and this is D, right? So if I take 4 points on an ellipse and I try to draw the normals from those 4 points, and I find out the point of intersection of that normal points, and this is also called as the co-normal point. Okay, this point is also known as the co-normal points, right? So in case of an ellipse, if I consider the points from where the normals are drawn by the parameter theta1, theta2, theta3, and theta4. I hope you know what is this parameter theta. So theta is nothing but the eccentric angle of these points on the ellipse. So what we'll see that in case of co-normal points, so if these are co-normal points, then there is a standard result that theta1 plus theta2 plus theta3 plus theta4, this will be equal to an odd multiple of pi. Okay, so this is a very important relation that we can also see. However, I don't like to mention this kind of relation, especially for your exam. It is not that useful or important. However, if you are really interested and curious to know about some of the proofs, you may try to prove it as well. Okay, so I hope this is clear to all of you. So with this, I think we are done mostly with the different properties of the ellipse, right? And if I feel that there are some other important properties, I would like to definitely mention them along with the questions. Okay, so let us now come to the discussion on the question answer session. Okay, is it clear to all of you? Do you have any questions? Okay, sir, how to join? We will learn how to calculate the area or the length of the arc or the curves, right? So this is something that you can take up as an advanced calculus lectures. Okay, so I am leaving this part up to you. If you want, if you're really curious to know about it, you can definitely go in and check it out, right? So actually there is something called as complete elliptic integral of second kind, okay, which I don't want to teach right now. Okay, all right. So with this part, I think we are mostly done with our discussion, and so now let us quickly go on to solve some of the previous year JEE Mains problems, right? Okay, so I have got some problems over here. I hope you can see the questions on your screen. So I would like all of you to try this question once. Okay, so give a try and then we'll discuss about the solutions quickly. Okay, is it clear to you everyone? Is it clear? TV gaming, is it clear to you? So as it is mentioned that the ellipse satisfy, so E passes through this point 1 comma 2, therefore it will satisfy this equation, and if I solve it, we'll definitely get the value of p, and if you solve it, it will turn out to be something as 1 upon 4. Okay, so this value will turn out to be 1 upon 4, right? So once we get this value of p, then I can easily find out the eccentricity of this particular ellipse. So the eccentricity of this ellipse will be coming out as 1 minus b square by a square. So in this case it is a vertical ellipse, so in this case it will be 1 minus a square by b square, right, where your a square is 4 by 3 and your b square is 16, right? So this will turn out to be, so we will get the eccentricity coming out as root under 11 by 12. Okay, so we will have the eccentricity coming out something like this. Now if I have to find out the focal distance of a point C, let us assume that the C has a coordinate h comma k. and the focal distance or the distance of the point C, so that can be also given out by, we already know that the focal distance of any point is actually given as is equals to b times, so in this case is a vertical ellipse, so let me write it down over here, since it's a vertical ellipse. Okay, so in this case the focal distance is given as b times b plus or minus e times that x coordinate. In this case it will be y coordinate, right? So it will be e times k, right? So therefore CF1 would turn out to be 4 plus this eccentricity value multiplied with this value of c, that is basically 2, and CF2 will also come out as, so in the similar manner CF2 would be 4 minus square root of 11 by 12 into 2, right? So we will get the both the values, right? And as it is mentioned that this particular length is mentioned as small f1 and this particular length is mentioned as small f2, right? So therefore having these two distances, and we also know about the radius, so if I perform this particular expression and if I calculate it out, you will see that it will turn out to be some value around 70. So with this we'll get the final answer to this question as option number C. I hope this is clear to all of you. I hope this question is clear. Is this clear to all of you? Is this part clear? Do let me know in the live chat, is this part clear or not? Okay, so maybe I will try to discuss about it again if you are having any problems. Okay, so I hope you are all getting the answer as 70, right? Now again another question where they are asking you to apply the concepts of application of derivative and also the concepts of ellipse. Okay, so this is one of the very simple example of such kind of questions where they will combine or club together two chapters to ask you questions. Okay, so this is a fantastic question. I think it's quite an easy, but however JEE Mains actually asks these kinds of problems, so therefore it is very important to actually practice these kinds of problems. Okay, so please try to solve this problem so that I can discuss about the solution soon after that. Okay, so give a try. Just give a try and then we can discuss about the solution to it. Okay. Just give a try. So if you read the problem, it is said that for this particular ellipse, the length of the lattice rectum is given to us as 10 units. And if the eccentricity is minimum value of this particular function, then I have to find out these values of a's and b's to evaluate a square plus b square, right? So before I proceed, let us first of all find out what is the minimum value of this kind of function. To proceed for the minimum value, I'll just differentiate it with respect to t, and that will turn out to be 2t plus of 1. And if I equate it to 0, I will get the critical point or the critical value of a to be minus of half. And if I find out the second derivative of this function at this value t is equal, so for this particular function, the second derivative is again going to be a positive number. Okay, so second derivative is a positive number, so that means that this is the minima, this is the minimum point. So therefore the minimum value to this function will turn out to be at t is equal to minus half, and that will be 1 by 4 plus minus of half and plus 11 by 12. Okay, so if you solve this, the minimum value to this function would turn out to be, so we'll have the minimum value of this function f of t, the minimum value to this function will turn out to be 2 by 3. Okay, the minimum value to this function will turn out to be 2 upon 3. So there, that means that this is my eccentricity value, right? So once I have the eccentricity, we know the eccentricity formula. So I'm assuming a is greater than b, so the formula is 1 minus b square upon a square, right? And that is equals to 2 by 3. Sorry. So that is basically mentioned in the problem to be equal to 2 by 3. Again, we know the length of the lattice rectum, that is basically for this kind of ellipse, it will be 2 times b square upon a. So this will give us the lattice rectum length, and that is known to us. It is basically given as 10, right? Also from the eccentricity equation, then I can rearrange it to get this value as 1 minus b square upon a square. So we know the eccentricity square value will be 4 upon 9, and that is equals to 1 minus b square upon a square, right? And this will give me the result for b square as, so from here I'll get a relation as b square is equals to a square times 1 minus 4 by 9, that is 5 upon 9. So this is one of the equation in a and b, and again from another equation of this particular form we can evaluate to get a's and b. So if you solve this equation 1 and equation 2, you'll get the values of a and b. So from here you will get the value of a as 9, and value of b square would turn out to be 45. Okay, so therefore a square will be 81 and b square is 45. So therefore the sum of this a square plus b square finally would turn out to be 126. So with this we'll have the answer to this problem as option number D. Okay, I hope this is clear to all of you. I hope this question is clear. Anshu, hi bhaiya. Ansh, hello Ansh. Okay, are you able to solve this problem? Are you able to solve this problem? Are you all getting the answer as option D? Tell me. Ansh, correct. Very good then. Okay, then Ansh, can you proceed with this third problem? Can you try to solve this third problem, Ansh? This is another very interesting problem. And again, here they have asked you or given us the area of the triangle. Okay, so again we have to play around with geometry. Area of this triangle is given and the length of the major axis is given. So for this kind of ellipse, we have to find out the distance between the foci. Okay, correct, Ans. So please try to solve this, Ans. Can you quickly tell me which of the following will be the correct answer? Try to solve it. Try to solve this problem. Okay, this is interesting problem. So here we will have an ellipse intersecting with a circle. So we have the ellipse something like this, and the circle is something like this. Okay, and let us say the one of the point of intersection is point P, and so the circle, uh, such that the circle C and the ellipse intersect at 4 points. Okay, and the circle is passing through the foci f1 and f2. So let us consider these are the focus of this ellipse, that is f1 and f2. The circle is passing through it, right? And in this case, we'll obtain this particular part as 90 degree. That means that f1 f2 is the diameter of the circle. Okay, f1 f2 is the diameter of the circle, and that basically means the circle equation can be given as x square plus y square is equal to ae whole square, because the distance between the f1 f2 is 2 times ae, 2 times ae, so the half of it is going to be the radius, right? Okay, so this is some of the hints I've already given to you. And then if we compute the area of this triangle pf1 f2 is 30 square units. So the area, is very simple. It should be coming out as half times 2 times ae multiplied with this perpendicular distance, and the perpendicular height, if you again evaluate this perpendicular, will turn out to be, so this can be easily obtained by obtaining the y coordinate of this point P, right? And the y coordinate can be obtained by substituting this y square or this x square in this equation, and then we can solve for it. Okay, so if you solve it, the y coordinate will turn out to be b square upon square root of a square minus b square. Okay, this will be the height of that particular triangle, right? And this is given out as 30 square units. Okay, so try to simulate or try to simplify this sum of the algebra, and finally you will obtain the result. Okay, so try to solve this quickly. Try to solve this problem. I've already given you some of the hints. Okay, and also the length of the major axis, that means 2 times a is given as 17, right? So from here a is given as 17 by 2. So we already know the value of a. The only thing we need to know is the eccentricity, right? Or maybe we can solve this equation, or we can substitute this e with respect to b, and you can solve it any of the variables. Okay, so it's up to you how you solve it. Okay, I'm leaving it to you. Okay, so finally you will get the answer as coming out to be Option C. Okay, so I have already solved it. So I got the answer as option C. I think all of you must be getting the same answer. Any questions? Any question, anyone? Yes, no. Is this part clear? Are you all getting the answer as 13? The distance between the foci of the ellipse is coming out to be 13. That is 2 times A into E should come out as 13. Are you all able to get this? Are you all able to get to this answer? Do let me know in the live chat. Is it clear to all of you? Okay, so with this part, we almost come to the end of the lecture, and then I leave one of the question where here the question is basically asking you to find the equation of the chord whose midpoint is already known to us, right? So if you recall, the chord equation of the chord with a midpoint is actually given by this form, that is t is equal to s1, right? So if you apply this transformation over here, which we have already learnt in our previous topics of circles, you will be able to get to the final answer. Okay, so please try to solve it and do let me know whatever answer you get in the comments after the live class is over. Okay, so with this we come to the end of today's lecture, and with this we are finished with the ellipse. So from tomorrow onwards we are going to start with our new chapter, that is going to be hyperbola. Okay, so from tomorrow onwards we're going to we're going to start with hyperbola and also try to finish it as soon as possible, so that we are almost done with our coordinate geometry portion for our JEE mains. Okay, so with this chapter of hyperbola will mark the end or completion of our topic of coordinate geometry. Okay, so I thank you for your lovely attention over here in this channel, and please don't forget to subscribe to the channel and also hit the bell icon so that whenever we are live on this channel you get a direct notification. Okay, so with this we meet again tomorrow at the same timing and with the topic of hyperbola. Okay, bye bye, take care and all the best.